Okay, we take a look at question 16. This is your review packet. And again, I'll say to you, make sure that you can attempt these questions on your own, and then copy the notes down in your packet as a review or study guide. Okay, question 16. Again, we're dealing with graphing questions and some other pieces. So question 16, we have the equation negative x squared minus 2x plus 8 is graphed on a set of axes below. Based on the graph, what are the roots of the equation? Again, when we talk about roots, roots are going to be also solutions, another word for them, and zeros. And when we take a look at the roots or solutions or zeros, this is where the graph crosses the x-axis. All right, and that's because this is where y is equal to 0. All right, so if we take a look at the graph, we're looking at 2 points here. This point and this point is where it crosses the x-axis, and that's going to be at the point x equals 2, and then 1, 2, 3, 4, x equals negative 4. And that's going to be choice 2. And we're done. All right, next question. This is something that we recently took a look at, rational expressions. What is the sum? And again, the first thing we're supposed to realize is what is the operation that we are performing on these two fractions? And that is sum, which means we're going to add. And when we're adding fractions, we must come up with that LCD. So you take a look at the least common denominator. The least common denominator, they both have something already in common, which is x, so that'll stay. And then the least common multiple, if you will, of 2 and 3, which will give us that least common denominator, is going to be 6. And then you go through that routine of what did I multiply 2x by to get 6x, and that answer is 3. And I do the same thing to the top, and 3 times 3 is 9. There's your plus. And then what did I multiply 3x by to get 6x, and that answer is 2. Multiply the top by the same number, because 2 over 2, 3 over 3, it's multiplying by 1. We're changing what it looks like, but we're not changing the value when we multiply by 1. 4 times 2 is 8. We get 17 over 6x. Check to see if anything can be reduced. Nothing can be reduced. We look for that answer, and we're at choice 2. Okay, moving on. All right, again, now this is going to be more or less how to take a multiple choice question test, especially with this piece. When you take a look at this inequality, all right, 3y minus 9 is less than or equal to 6x. What we're supposed to do is we're supposed to solve for the y and state the slope and state the y-intercept and then try to graph it. But if you take a look at all four of these graphs, the line that's there is basically the same line. All of these lines are the same. What's different about them is in choices 1 and 3, they're solid. And in choice 2 and 4, they're dashed. And in notice in choice 1 and 2, it's shaded below. And notice in choice 3 and 4, it's shaded above. All we have to know is what this inequality means in terms of what the line is supposed to represent. If it's less than or equal to, we're supposed to know less than or equal to, greater than or equal to. The line has to be solid. It's a solid line. Because of the word equal to, we include all the points on the line in the solution set. All right? And just for the note's sake, if it's less than or greater than, and you don't say equal to, this is when it's dashed. Okay? This is a dash line. All right. So right away we see less than or equal to. We can throw out choice 2 and we can throw out choice 4 because they're dashed lines. Now the other piece to graphing inequalities is the shading part. And when we worked on shading, we labeled our work shade, and then we picked a point that was definitely on one side of the line. 0, 0 is definitely on one side of the line. We wrote our equation down, 3y minus 9 is less than or equal to 6x. And we plugged in 0, 0 to see if it made the inequality true. We plug in 0 for y, we plug in 0 for x, and we wind up with 3 times 0 is 0 minus 9. We get a negative 9 is less than or equal to 6 times 0 is 0. Is negative 9 less than or equal to 0? That is true. Since it is true, the side of the line that contains 0, 0, so here are the two choices that are left. Which one of the two choices that are left contains 0, 0 in the solution set? That would be this one. Because remember, if it makes it true, we shade that side or that half that 0, 0 came from. So the answer is choice 1. All right, now we jump down to question 21. Question 21 is, again, one of the ones we recently took a look at, rational expressions. And anytime you see a couple of x squareds over one another and we're trying to, write this in simplest form, please do not start crossing things out. All right? You can't cross out things if they're attached to other things, other terms with pluses and minuses. So we must think to factor first. So factor first. So this problem just becomes, how do we factor x squared minus 2x minus 15? And how do we factor x squared plus 3x? We do both of those pieces, and then we look to see what we can cancel. Well, this is a quadratic. It has no GCF. It's not the difference of two perfect squares. Okay, so it's a quadratic. It's going to factor into two binomials, as we talked about in class. Since it's just x squared, we're dealing with x and x. We take a look at the constant, which is the 15. Its sign is negative, so we know our signs are going to be different. And we're looking for factors of 15 that could add up to be 2, having different signs. And the only factors of 15 that has a difference of 2 would be 5 and 3. And we want it to be a negative 2, so we put the larger number next to the negative sign. And we put the smaller number next to the positive sign. So we get a negative 15 when we multiply, and we get a negative 2 when we add. So that's factored perfectly. We take a look now at the bottom, and we start off with a GCF. What's common with these two terms is an x. We take that x out. We have two x's here. We took one of them out. That's going to leave an x inside, then plus. And then we took an x out of the 3x. That's going to leave us with 3. And you can just double check. That's x squared and that's 3x, so we're good. Once you have everything factored, now remember, you can't cancel anything out if it's attached to a plus or minus, but you can cancel the entire term out, which is what we do there. I can't cancel these two x's out because this x is attached to that 5 with that minus sign. So we leave it, and we get x minus 5 over x, and that's going to be choice 2. Next piece, bottom question, it says, what is the equation of a line that passes through the point 4, negative 6, and has a slope of negative 3? Well, first of all, we look at the fact that y equals mx plus b, and they're telling me that my slope has to be a negative 3. So the number in front of x has to be a negative 3. We know that. So the first thing I'm going to do is see if there's anything that I have to worry about here, maybe canceling a choice out. And the answer is no. So now we're looking for, so all of these lines have slopes of negative 3. Now we're looking for which one contains the point 4, negative 6. In order to check this out, we just simply take the number 4 and plug it in for x, and we plug the negative 6 in for y, and we see which one is going to work. So in the first case, we got negative 6 goes in for y, then equals negative 3 times 4 plus 6. So we have negative 6 is equal to negative 12 plus 6. We get a negative 6 is equal to a negative 6. And guess what, guys? We're done. That's it. That's the one that's going to work. All right, if you wanted to, you can check and plug them into all the rest, and they don't work. Moving on, question 23. Now, question 23, it's an easy question. You guys know how to do this one. You just have to remember what it means to subtract from. So what I'm going to do is I'm going to say, okay, let's say 3 is subtracted from 5. If 3 is subtracted from 5, remember we start with 5 and we take 3 from it and we get 2. We have to set this up the same way. If 4x squared minus 7x minus 5 is subtracted from, that means we're going to start with 9x squared minus 2x plus 3 we're going to subtract from that and then put in parentheses, because this is the polynomial that follows, 4x squared plus 7x minus 5. And then if you remember, what we do is we rewrite the first polynomial, and that you can either call this distributing the minus sign through, or we change the minus to a plus, and every single term that followed that minus sign changes signs. And then our last step is to combine like terms. 9x squared, negative 4x squared, 5x squared. Negative 2x, negative 7x, signs of the same atom, negative 9x, plus 3, plus 5, plus 8. So I'm looking for 5x squared minus 9x, no good. 5x squared minus 9x plus 8, choice 2. All right, 2 more for right now. Question 24. Question 24, we have y equals x squared plus 3x minus 18. It's graphed. You see it here. All right, it says based on the graph, what are the roots of the equation? All right, we talked about this before. We just did one like this a couple minutes ago. When you're looking for roots of the equation, you're looking for where the graph crosses the x-axis. So we see it here, and we see it here. So that's going to be at x equals negative 6 and x equals 3. Okay? And the last one that's on this page is we have what is the value of the y-coordinate of the solution to the system of equations. Now once we start looking at a system of equations, you know, think about it. We have x's and y's, x's and y's. Remember, let's try to quickly solve this algebraically. So to do that, we are going to line up, rewrite the equations if we have to, but we're going to line up all of our variables. So our x's and our y's and our constants are all in the same thing. And what we want to do is we're interested in which coordinate. It says the y. So we want to basically cancel the x's out. So what I'm going to do is I'm going to subtract these two equations. And watch what I do. I make sure I go to that minus sign each and every time, because this is where we can make a mistake with the signs. So here we go. X minus x, 0. 2y minus a minus y. Well, that becomes a plus y. So we get 3y equals 9 minus 3, 6. Divide by 3, divide by 3. Y is equal to 2, and we're done. Choice 2 again. We're getting a lot of choice 2s. All right. I said that was it, but we'll go 2 more. All right. So now we're on page 4 in the packet, question 29. Again, a statistics question given a graph. So we have a movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box whisker plot shown below represents the data for the number of tickets sold in hundreds. So these are hundreds. That's 100, 200, 300, 400, 500. So make sure we note that. Which conclusion can be made by using the plot? So now you just go through the choices and see what's going on. It says the second quartile is 600. Well, remember, this is our low score in a box whisker. That's our Q1. This is our median. That's our Q3. And then this is our high. So our second quartile is right here, which is our median. I guess we can call that our Q2. Same thing, 600. Nope, it's 400. No good. The mean of the attendance. Well, based on a box whisker, if we have no other information, we can't determine the mean. The range of the attendance, well, the range is going to be, again, definition of range, it's going to be high minus low. Well, our high score here is 900 minus our low score, which is 100, so the range is really 800. They said our range is between 300 and 600, and that's no good. It's between 900 and 100. And then 25%. So this has to be our answer, but 25% of the attendance is between 300 and 400. Well, here's 300 and 400 right here. 25%. Well, let's take a look. If we bring it up to that box whisker, remember, between Q1 and the median, that's 25% of the scores. So 25% is between 300 and 400. We're good. All right. We go down to question 30. In question 30, we covered this recently too, is in terms of how to tell whether graphs are functions. Which graph represents a function? Remember, a function has this, for every x in the domain, every x in the domain is sent to one and only one member in the range. You have to have that, you can't have an x going to more than one y. And we said that when we're given graphs, one of the quick ways to test if a graph is a function or not is give it the vertical line test. And if a vertical line hits the graph more than once, it's not a function. So this is not a function. I draw a vertical line, hits it more than once, not a function. This one, be careful. If you draw a vertical line on the vertical line, you get, actually it's hitting it way more than once. It's infinite many times, so this is still not a function. And if I take a vertical line and draw it through, you can take any vertical line and draw it through this graph. It's only going to hit it one time. This is the one that's going to be our function. Choice 4.